Okay, let's keep talking about how we're breaking up this data. Sometimes we don't want to look at the data as a big, huge pile, right? It's so much, we got to break it into categories. And these categories that we're talking about are called classes. So classes are just categories where we group them up so we can work with the data easier, all right? Instead of individual pieces, we're going to group them up. Now, a lower class limit, so a class goes from the bottom to the top, right? So this whole group of data that's an R, this whole group of data, within that group, there's a small value and there's a big value. That's the lower limit and the upper limit. That's what we're talking about. So the lower class limit is the smallest value in the class. So the upper class limit, the largest value, right, in the class. And that's just a group. So we're using the word class to represent that group. Now the width is from the lower to the upper. So you're just going to take the difference, or you subtract, right, upper minus lower, and that's going to give you the width. How much is between there, that's going to be that width. So it's the upper class limit minus the lower class limit, right? It's just the difference between those two. This is a minus sign. That means difference. All right? Okay, so here's a representation of that. So in this table 12 represents the total fine, including late penalties in dollars, for simple random sample of 50 parking and camera violations in the city of New York. Construct a frequency and relative frequency distribution of this data. So there's a lot of data. I am not going to try to see, if I'm looking at this, we are not going to categorize 211.09. That gets its own category. 105 gets its own category. That's crazy. That is crazy. That's where we use classes or groups that we're talking about. All right. So the first thing we have to decide is what kind of group are we going to set up, and this one's done for us. Whenever you make your own, you're just going to make that determination. What makes sense? Looking at my data, what makes the most sense that we're going through here? Okay, so they already have it grouped up for us. Now check this out. If I'm just looking at this first one right here, tell me what is the lower class limit of this one? 50. Nice. What is the upper class limit? 74.99. Good. Now here's where it gets awesome. If I'm looking at my lower and my upper class limit, if I were to subtract these, you would get 24.99. Well, when we're talking about class limits, we're just going to round it to the nearest value. So if I want to find the width of this classes, it's going to be 25 as the width. We're not getting down to the specifics. Now check this out. In order for me to tally these up, I have to look at 74.99 and the next. So the lower limit, they're all rounded off numbers. Do you see this? My lower limit's all rounded off numbers. The upper limit is just up to the next thing. Could I have this as 50 to 75? No, because if I'm going to tally this and this one went to 75, how am I going to know which one to tally that one into if I'm straight up $75? I don't know. That's the key. So that's why this one goes to $74.99, and your lower limits are always that rounded off value that I'm looking for. But we're still saying the width is 25 here that we're talking about, because it's basically 25 that we have. But I can't write both of these as 75, because if I'm looking for 75 in my lineup, I wouldn't know which one it went with. Does that make sense? Okay, so this is the lower We've got the upper, and then the width is how much is between. When we subtract those, it gives me 25. Now, you can go through here. These have already been tallied up. So you figure out how many there are. That's your frequency. You get your relative frequency. The same thing applies if we're looking at these problems. We can add these up, and then it'll give us how many? 50 of them. We can add up the relatives, and it'll add up to 1. Yep, exactly. You guys are on this. I love it. All right. And then I just want to show you, we can construct these frequency and relative frequency charts. It doesn't have to be qualitative. We can have it as quantitative. Now notice this is a histogram. What makes this a histogram again? Yep, those bars are touchy. And look what else is happening. I'm going to make this bigger. We know that I'm going from 3 to 3, 24.99, but that's going to take us in between here. Do you see how my histogram is going between those values? So the bar is actually looking at that width. Also notice, what is this width? Is 25. My lower limit is 50. My upper limit is 74.99, but it goes right up there to that 75. Do you see what's happening? And that's what makes a histogram. That's why it's not just a bar graph. That histogram a lot of times has those class widths that you're talking about. So you have that frequency or relative frequency. You can do either one, whatever you're talking about, right? But that's where those values come from there, and that's what makes this a histogram. Those bars are touching, and they're showing the lower limit, the upper limit, and so you can see that width also represented in there. Pretty cool, right? Yeah, I think so too. That's pretty awesome. So we're just still looking at the same types as we're going through here. One more type that I want to look at here is a dot plot. A dot plot. Now this one's rarely used. It's not hardly ever used, but still want to show it to you just so that you have a good idea about what's happening. So you draw a dot plot literally by placing dots. So each observation horizontally in increasing order, and then place a dot each time it's observed. So it wouldn't work very well with the fine example, but our Wendy's example, because we have individual. So I'm going to swing back over here real quick. Notice we can tally these up for individual values, and I have this frequency. So on a dot plot, the 1 gets 1 dot. The 2 gets 6 dots. The 3 gets 1 dot. Do you see how this is playing out? 1 dot. 1, 2, 3, 4, 5, 6 dots. 1 dot. That's a dot plot. Do you notice over here? Check this out. Is there anything on this vertical axis? Nothing goes here. Because there's nothing to represent, because the data is represented in the dots. So I don't have to have some type of a frequency over here because it's represented in the dots. Now, a dot plot's not used very often, right? But I still want you to be aware of what's going on with it. So we put that in here. Lots of learning going on.